start off, we want to take what is given, which is a equals x over 2. You plug that into the h equals a squared plus y squared formula. Once you plug this into here, you take this part of the equation and plug it into a equals 2xh. Using this equation, it'll help you find your y variable. So to do that, you say a equals 2x, the square root of x over 2 squared plus y squared. So your goal is to isolate y. And to do that, you want to divide by 2x on both sides, which gives you 8 over 2x equals the square root of x over 2 squared plus y squared. Then you want to get rid of the radical, and to do that, you have to square both sides, which ends up giving you a over 2x squared is equal to x over 2 squared plus y squared. You want to continue to get y by itself by subtracting x over 2 squared on both sides of the equal sign, which gives you a over 2x squared minus x over 2 squared is equal to y squared. Finally, to isolate y, you square root both sides of the equation, which gives you y equals the square root of a over 2x squared minus x squared over y. We'll use the equation b equals 1/3 x squared times y. We plug in what we found earlier, which is y equals square root of a over 2x squared minus x over 2 squared. That gives us b equals 1/3 x squared, square root of a over 2x squared minus x over 2 squared. Get rid of the 2's in the denominator, and to that we have to multiply the outside by 2. That'll get rid of these 2's, which gives us 1 over 6 x squared, square root of 8 over x squared minus x squared. To get the x's with these on the inside of this radical, we have to turn this one into its radical state, which gives us 1 over 6 square root of x to the 4th times square root of 8 over x squared minus x squared. Now to get this radical into this one, we multiply it into there, which gives you 1 over 6 square root of x squared times a squared minus x to the 6th. Now we have to find the derivatives of both parts, which is dv over dx is equal to 1/6, and d over dx is the square root of x squared over a squared minus x to the 6th. Now to get this radical into the exponential form, which gives us v equals 1 over 6 times x squared times a squared minus x to the 6th to the power of 1/2. Now we can start working out the derivatives. So we got v equals 1 over 6 times 1/2 times x squared times a squared minus x to the 6th to the power of negative 1/2. We start by multiplying the negative 1/2 times part gives us the derivative of the inside part of the equation, which is 2x times a squared minus 6x to the 5th. Using what was given in this equation, we have 0 equals 1 over 6 times 2x times a squared minus 6x to the 5th all over 2 times the square root of x squared times a.
Volume equals 1/3 x squared times y. And then you plug in the previous values, which gives us a volume of 1/3 times 22.26 squared times the square root of 858.9 over 2 times 22.26 squared minus 22.26 over 2 squared, which gives us the optimized value of 2,601.41 centimeters cubed. Then you plug in the original volume of the pyramid minus the optimized volume of the pyramid over the optimized volume of the pyramid. We multiply that times 100, which equals to negative 2.15%. Isolate the variable of y using the equation. Volume equals 1 over 3 x squared times y. And we already know these values, which is x equals 22.26. And the value of the volume, which is 26 over 1.41, and we plug that into this equation, and we get this. Now next step is canceling the 3, so you multiply times 3 and 3, and then you get 22.26 squared, and then the 3 times 4 is blah blah, and you get 7,804.23 over 495.508, which equals to 495.508 times y over 495.08. And you get y equals 15.75. 5% error value, you use the original value of the pyramid minus the optimized value of the pyramid over the optimized value of the pyramid times 100, which equals to negative 2.84%. Find h using the equation square root of x over 2 squared plus y squared. We already know the value of x and y. See right here, 22.26 and 15.75. use those equations and plug it into these equations, giving you this. And you plug that into the calculator and you get square root of 371.939. Plug that into the calculator and you h equals 19.28. We use the original value of the pyramid minus the optimized value of the pyramid over the optimized value of the pyramid times 100 equals negative 3.31% error.
Here we're given the values of S, which equals 22.27, Y equals 50.75, and A equals 11.13, and H equals 19.29. So to start off with, we got tangent alpha, which equals Y over A, and then we need to find the inverse of tangent. So we plug in the values, so we put 15.75 over 11.13, which equals alpha, and as a result, we have 54.75 degrees. And we have the original value of the pyramid minus the optimized divided by the optimized times 100, which equals negative 5.26% error. And so over here we got sine beta, and we need to find the inverse of this, so we plug in y over s, so we get 50.75 divided by 22.27, and as a result we get 45.53 degrees. That's what beta equals. And then we get the original minus the optimized divided by the optimized times 100, which gives us negative 7.73% error. And then over here we got sine sigma, and we need to find the inverse of that, so we plug in 2 times h over x, which is the values over here, and then we get 2 times 19.29 over 22.26, which equals sigma, and as a result we get 60.01 degrees. And then we got the original minus the optimized divided by the optimized times 100, and it gives us negative 2.84% error.